Hello everyone. Please let me know if I am audible and my screen is completely visible to you. Anyone, just drop a comment so that we can start. Anyone, drop a comment so that we can start. Okay, so we are starting. So in the last lecture we have seen this disjoint sets union. Okay, so let us take a small recap of the disjoint set union, what it is. So basically disjoint set union is basically used for if like you have two sets, say 1 2 3 is one set, 4 to 4 5 6 say is another set, and say 7 8 9 this is another set. So suppose we have these three sets, okay, and if we want to combine some of these sets, and if we want to query in these sets, then basically this disjoint set unions is basically used. So now suppose if we want to combine these two sets, that means suppose we want to combine this 2 and 5, so this means that we want to combine the sets which contained in which this element 2 is contained, and the set in which this element 5 is contained, and what we are doing is we are taking the union of these two sets. Okay, so in this what we were doing, we are just taking this thing. Okay, like if we take the union of these two things, we will be getting 1 comma 2 comma 3 comma 4 comma 5 comma 6. Okay, so this would be our resultant set after doing the union operation. So and it is also used to like search if any two elements belongs to the same set or the different sets. So for example, if we are talking about here, if we are talking about 2 and 8, so this 2 and 8 belongs to the different set, and 2 and 4, so this 2 and 4 belongs to the different set. So it is also used by the for these kind of queries. Okay, for resolving these kind of queries. So yes, this is nothing but the disjoint set union. Uh, Talking about the implementation part, what we have seen in the implementation part. Okay, so in the implementation part, we have implemented two functions. One is the find, and the another one is the union function. Okay, or say unite function. So and the UNI, this is the name of the function we have implemented. Okay, so what we are doing in the find x function, so it is representing the set in which this element x is contained. So basically, like if this is the bigger set, and in this 1 2 3 4 5 6 are contained in, so suppose if you are finding the find 2, then this set would be returned. So we are not going to return this complete set, but the representative of set. Okay, but the representative of set, and any element among them would be the representative of this set. So that is what this find x is returning. Okay, so and what union x comma y is doing, so basically it is taking the union of the set in which this element x is contained and the set in which the element y is contained, and after taking the union of these two things, it is like this would be something like this. Okay, so this is what we have done in the last lecture, disjoint set union, and we have already seen the time complexity of both the operations. So the time complexity of both the operations was order of alpha of n. Okay, where n is the size of the input. Okay, and what is alpha? Alpha is nothing but the inverse Ackermann function that we have already discussed. Inverse Ackermann function. So this we have already discussed in the last lecture. So this is just for the precap. Now today what we are going to do is this problem particularly. Okay. So let me read this problem statement. What this problem statement says. So this problem statement is given an array A with n non-negative integers. Okay, so suppose we are given an array, this is our array, okay, and we are given with this array, and say the size of this array is n, and say the name of this array is A. Okay, and the strength of the segment is defined as the minimum element of the segment. Okay, now this, what is the strength of the segment? So suppose if we are talking about the segment S L to R, like if the L point is here and the R point is here, then the strength of this segment L to R is defined as the, like this would be some element, this would be some element, this would be some element. So the minimum of all these elements is defined as the strength of the segment. Okay, so this would be the minimum of all the elements from AL plus 1 all the way to AR. Okay, so this is defined as the strength of the segment. Okay, and then the function fx is defined as the maximum of the strength of all the segments of size x. Okay, what fx is defined as, so and the fx is defined as, we will be taking all the segments, all the possible segments of size x, and we are calculating the strengths for all those possible segments. So suppose if s1, say s2, s3, s4 are the say strengths of all the possible segments of size x, then the maximum among all these values is defined as this f of x. Okay, so this is how the strength and f of x is defined. Now what we have to find is, find the value of f of x for each x such that x is greater than equals to 1 and it is less than equals to n, where n is the size of the given array. Okay, now suppose if we are talking about f of 2, now what would be f of 2? So f of 2 would be, we would be considering all the say segments of the size 2. So this would be one segment, let me take some other color. So this would be one segment, this would be other segment, this would be other segment. Okay, just like this. So we will be calculating the strengths of all these segments, and then we will be taking the maximum of the strength of all these segments, and that we would say as our say strength, say f of 2. Okay, so we have to create a resultant array, and that resultant array would also be of size say n, and for each of this I, what we have to do is we have to calculate the f of I. Okay, like for one size segment what would be the f of 1, and for two size segments what would be the maximum value of all these strengths. So that we have to calculate, and then in last we have to return this particular array, or we have to output this. So this is our problem statement. To make the problem statement more clear, we can take example. So let me erase this, this is just for the understanding of the problem statement. Okay, now let me take example. So suppose we are given n equals to 4, okay, and the array is something like this, 1 2 3 and 4. Okay, so 0 1 2 3, this would be the indices, and say the elements of the array is 4 3 5 and 7. Now what we have to do is, we have on this particular given array we have to calculate a resultant array. So this is our given array A, and say this is our resultant error res. Okay, so now what we will be doing, first we will be finding all the segments of the size 1. So all the segments of the size 1 would be 4 comma 3 comma 5 comma 7. Okay, so these are all the segments of size 1. Now the strength of first would be 4 itself, because the minimum of this segment is 4, the minimum of this segment is 3, the minimum of this segment is 5, and the minimum of this segment is 7. Okay, so this is for say x is equals to 1. Now we would be taking the maximum of all these values, and that is nothing but 7. So the f of 1 value would be 7, so we'll be writing 7 here. Now we'll be taking all the segments of size 2. So suppose if we are taking x equals to 2, So this if you are taking all the segments of size 2, then that would be 4 comma 3, this would be one, 3 comma 5, this would be another, and 5 comma 7, this would be another segment. And if you are say calculating the strength of these segments, so the strength of these segments would be say the minimum of 4 comma 3 is 3, the minimum of 3 and 5 is 3, and the minimum of 5 and 7 is 5, and we have to take the maximum of all these values, and that would be our f of 2. So the maximum of all these values is nothing but 5, so we will be writing 5 here. And similarly for x is equals to 3, we will be finding all the possible segments of size 3, so that is nothing but 4 comma 3 comma 5, this would be one possible segment, and the another possible segment would be 3 comma 5 comma 7, and then we will be calculating the size of the strength of this segment. So the strength of this segment is the minimum of all these elements, so that is nothing but 3, and then we will be calculating the strength of this particular segment, so that is nothing but the minimum of all these elements, so again that is 3. Okay, and then what we have to do is we have to calculate the maximum of these two values, so that is nothing but 3. So the value of f of 3 is nothing but 3. Okay, and then for 4, for x is equals to 4, we'll be taking out the segment with the size 4, so that is nothing but the complete 4 3 5 7, the complete array itself, and the minimum element of this one is 3, so the strength of this segment is 3, and we'll be taking the maximum of all the possible segments, so that is nothing but 3 again, so the f of 4 value would be 3. So the result for this is nothing but 7. Let me write it in some other color. So say the result for this one is 4 comma 3 comma 5 comma 7. Okay, so this is the result. So this was the array, this is not the result, this was the given array. The result is 7 comma 5 comma 3 comma 3. Okay, so this is our result that we have calculated manually. So now let us take a look at the algorithm, how we are going to solve it. So this is our solution, we know that because we have calculated it manually, but how we are going to solve it programmatically, that we have to discuss. Okay, so now we can erase this thing. Okay, this thing is remaining. Okay, I think the problem statement is clear to everyone, like what we have to do in the problem. Anyone having any doubts in problem statement, please just drop a comment in the comment box. Anyone having any issues in understanding the problem statement, just drop a comment. If you have any doubts, just drop a comment in the understanding of the problem statement, otherwise I would be moving to the solution part. Okay, now let us take a look at solution. So first we'll be starting with the naive solution. Okay, naive approach, or say brute force approach. Okay, so understood. Okay, someone is saying understood, fine. So what could be the naive approach, or say the brute force approach for solving this kind of problem? So what we can do is we can run a for loop for all the x from 1 to n, like for each of the x, what we can do is we can first find all the possible segments, okay, find all the possible segments, then calculate the strength Okay, then calculate the strength and then find the value of the function. Okay, this would be the brute force approach of doing this thing. Okay, now suppose if you are given an array like this, then what you can do, first you can move traverse for x equals to 1. So for x equals to 1, this would be a possible segment, this would be a possible segment, this would be a possible segment. So how many possible segments are there? So n segments are there for x equals to 1, and for each segment you have to find the minimum value. Okay, and then for x equals to 2, this would be a segment, this would be another segment, like this. So n minus 1 would be the segments, just like this, and then n minus 2 for the x equals to 3. Okay, just like this. So for x equals to n, we would be having 1 segment, and for each segment, like for each segment L to R, you have to first find the strength. Okay, so what would be its strength? So the strength would be minimum of from L to R. So for that you have to either use say like you have to use any of the say any of the range query structure. You can use any of the range query structure, just like segment trees. Okay, and then you can find this minimum of L to R. So this you have to do, like for each query there could be n segments. Here in this x equals to 2 you can have n minus 1 segments, in the x equals to 3 you can have n minus 2 segments, and for all these segments you have to first find the minimum value, and then you have to calculate the maximum value. So this would be your brute force solution. Now what would be the time complexity of this solution? Okay, let me move a little bit. So now let us try to analyze the time complexity of this one. So what would be time complexity? So suppose if you sum up these values up, then this would be 1 plus 2 plus 3 all the way till n. So this is the sum of n natural numbers, that comes out to be n into n plus 1 by 2. Okay, and this would be multiplied by a factor of log n, because for each of this segment you have to find the range minimum, and that you can do in the logarithmic time using the segment trees. Okay, so this would be something of the order of n square log n. Okay, and this particular thing is inefficient. We are searching some better solution. Okay, so now let us move to the better solution. Okay, so this is the naive approach, and we don't have to waste our time on the naive approach. Let us quickly move to the better solution. So better solution, what could be the better solution? Okay, so now let us draw some key observations. The first thing you can note is, the first point you can notice, f of 1 would always be greater than equals to f of 2, is always greater than equals to f of 3, is always greater than equals to like f of n. This condition always holds, and this is the most important observation in this problem. Okay, now why this thing always hold? Because suppose if you are having this array, and now suppose you are calculating the solution for x is equals to 1. Okay, for all the segments of the size 1. Now the best answer could be the maximum of all this all the elements, and say if this is 1 2 3 4 5 6, so these are the elements, so the maximum would be 6. So the best answer could be 6. Now suppose if you are trying to increase the size, now for this, suppose your x is now is equals to 2. Now if x is equals to 2, now what you are doing is you are trying to include some value along with this segment, or say along with this value you are trying to include some value to make it as a segment with the length 2. Okay, so now if you are including some value and this value is already the maximum of your array, or say the maximum of your vector, and again if you are including some other value, then in that case this value is either less than this one or it is equals to this one. So that means your solution, if the previous solution was f of x, then your solution for x plus 1 would always be less than or it is equals to f of x. So this is what we have done here. Okay, that is f of 1 is always greater than equals to f of 2, and it is always greater than equals to f of 3, and it is always greater than equals to, like, till f of n. So any doubts in this observation? Like, this is very intuitive. If you are having any doubts in understanding how we have written this and how we are coming up with this observation, you can just drop a comment, otherwise we will be moving forward. So this is the key observation for solving this problem. Okay. Now what we can do is we can sort the array in the decreasing order. We can sort the array in decreasing order. Okay, maintaining the index. That means we can take the vector pair and then sort it. Okay, so what we are doing is we are sorting the array in descending order, say non-increasing order, with maintaining the index. Okay, and then what we'll be doing is we'll be iterating from the largest, we'll be iterating from the largest to smallest. Okay, what we'll be doing is we'll be iterating from largest element to the smallest element, and what we will be doing is, for this, suppose if I am at current element, so what we will be doing is we'll be checking what is the largest length possible, for which this can be a solution. Okay, now suppose if this is our resultant array, which we have to return as our solution, will be for each element we'll be finding the largest length for which it can be a solution. Now suppose we are checking for x element, so we'll be checking what would be the largest length for which this x can be a solution. So suppose if the largest length is 4, so this is 1 2 3 and 4, so we can say that this x can be a solution for length 4. Okay, and if this x can be the solution for 4, at least it can be a solution for 3 also, and it can be a solution for 2 also, and it can be a solution for 1 also, by using the property that we have already discussed here at this point. Okay, and now suppose we'll be talking, like, suppose if we are talking about the element 5, and we'll be finding the largest possible length for which the y can be a solution, and suppose if it is 6, then this is 5, this is 6. Now if the largest length for this is 6, what we can say is the y can be the solution for this length 6, and at least y can be the solution for this one also, for this one, and for this one also. Okay, then what we have to do, we have to, like, mark all these things. Like, first we have to mark, for each element we can mark what is the largest possible length for which this can be the solution. Okay, and then we'll be marking this largest length. Suppose z would be somewhere here, and then after marking it, what we'll be doing, we'll be taking the maximum of each of these elements, and that will be our solution. So what we can do here is, we can just for each element we can just calculate the length, and we can just mark that particular element at this length. So this is x, and here we are having y, and then what we can do, we can traverse in the backward direction. We can traverse in the backward direction and we can keep comparing the maximum element, like we'll be comparing this element with this element, and which one is the maximum we'll be putting here. Then we'll be comparing this element with this particular element, and which one is the maximum we'll going to put it there also. And then we'll be checking this element with this element, and whichever value is the maximum we are going to put it here. And then in this way we are going to calculate our resultant array. So this is the idea behind the solution, and how we are going to implement it, that we are going to see later using the DSU. But this is the idea of the solution. Anyone having any doubt in the idea of the solution, just drop a comment. I can explain it again. If you are having any doubt, just drop a comment. Okay, so this is our idea, and then we are going to talk about the implementation part, how we are going to implement. Anyone having any doubt, just drop a comment. Okay, now let us move to the implementation part. Okay, thank you Saurabh for your inputs. Okay, now implementation, how we are going to do this. So suppose if this was your given array, then what we are going to do is we are going to sort the array, and after sorting array we are going to move from the largest array, largest element. And suppose if this is the largest element, then we are going to check its neighboring index. Now suppose if this is the largest element, we are going to check its neighboring element. If the neighboring element is greater than this value, suppose if this value is ai and this value is ai plus 1 and this value is ai minus 1, then what we are going to do, we are going to check if this ai plus 1 is greater than equals to ai, and if this ai minus 1 is greater than equals to ai. Because if this condition holds, then also the answer is going to be ai, and if this condition holds, then also the answer is going to be ai only. We can connect these three segments. Okay, so yes, suppose if this was ai, so for segment of length 1, ai is going to be the answer. And if suppose if this condition holds, that is ai plus 1 is greater than equals to ai, so this value is greater. So for the segment of size 2 also, ai can be a solution, because here this ai plus 1 is greater, so the minimum of these two values is ai only. And if this condition also holds, that means ai minus 1 is also greater than this ai, then the we can have a, say for this length equals to 3 also, we can have ai as a solution. Okay, so for each element we have to find the largest possible length for which this can be a solution. So what we will be doing, we'll be moving from the largest to smallest, and we'll be checking the each neighboring elements, and if the neighboring elements is greater than the current element, we are going to unite them using the union function of the disjoint set. Okay, and this is what we have to do. And at last, every time what we'll be doing is we'll be checking the size of the set. Okay, now suppose here you are having only a element, then you have say 3 as an index, then you have also these two conditions also holds, then you have say united say this 3 with 4 and this 3 with 2, then the set size would be 3 also, 3, because this 2 3 and 4 is gets connected. Okay, so this is how you are connecting these sets, and then you would be finding the maximum possible length at the last, what is the maximum possible length of that set, and you would be marking your result at that particular index in your resultant array, and then you will be traversing backwards. Okay, so this is what you have to do. Now we can dry run our solution also on this particular algorithm. So this is the efficient algorithm, and suppose it is more clear if we dry run our solution. The algorithm is more clear to you if we dry run our algorithm. So suppose if this is our given array, that is the given array is 4, 3, 5 and 7, and suppose we have to build a result on this array. Okay, now this is our resultant array. This is our resultant array. So this is 0, this is 1, this is 2, and this is not 0, but we have to start from 1 because it makes no sense to take 0 as the segment size. So 1, 2, 3 and 4. Okay. So now what we are doing is, first we'll be sorting this, and then we'll be traveling to the largest element. So this is the largest element, 7. So initially this 4, 3, 5 and 7 is behaving as the independent set with set size equals to 1. So first we will be moving to the 7 and we will be checking if any of its neighbor gets connected. So here this 5 is not connected with 7, cannot be connected with 7 because 5 is not greater than equals to 7 and its right neighbor doesn't exist. So this 7 is going to remain alone in this condition only, and then we'll be checking the set size of 7. So the set size of the 7 is 7 only. So what is the maximum length for 7? The maximum length of segment for 7, so that is 1 only. So what we'll be doing is, so 7 can be a solution for 1. So what we'll be doing, we'll be marking 7 here. Okay, and then we'll be checking. Initially this resultant array would be initialized by 0 only. Okay, and then what we'll be doing, we'll be checking for the next largest. So the next largest is nothing but 5. So we'll be moving to 5 and we'll be checking if any of its neighbor can be connected. So here this 3 cannot be connected as this value is less, but 7 can be connected because the 7 value is more. So what we'll be doing, we'll be taking the union of these two values. Okay, so if we take the union of these two values, we'll be having something like this. The set would be something like this, 5, 7. Okay, these are now our set. Then we'll be taking the set size of this because this would be the larger length for which the 5 can be the solution. So that is nothing but 2. Then we'll be checking what is the value that is already present at 2. So this is nothing but 0, and we are getting 5 as our solution and 5 is maximum, so we'll be putting 5 here. Okay, and then we'll be moving to the next largest element. So the next largest element is nothing but 4. Okay, and this 4, can we connect any neighbor of 4 to it? So the left neighbor of 4 doesn't exist, but if we talk about the right neighbor of 4, it do exist, but we cannot connect it because this 3 is lesser than 4. So the segment size of for which the solution can be 4 is nothing but 1, and if you move at 1 have already 7 placed. So in among 7 and 4, 7 is maximum, so we'll say put 7 here. Okay, and then we'll be moving to the next. So the next largest element is 3. So we'll be checking if any of its neighbor can be connected. So the neighbors are 4 and 5, and both of them are greater than 3. So we can connect this. So first we will be connecting the 4 and 3. So it will give the sets would be something like this. We will be taking the union of them, and this is 5 and 7, and then we will be connecting this 3 and 5. So what we are doing is, we are taking the union of the set in which 3 is contained and the set in which 5 is contained. So if we take the union of these two sets, we will be getting something like this, 4, 3, 5 and 7. And for this, so the largest length for which the 3 can be solution is nothing but 4. So we'll be moving to the index 4, and what is already placed at 4, so that is nothing but 0. So what we'll be doing, we'll be taking the maximum of 0 and this 3, so that is nothing but 3. So we'll put 3 here, and then we'll move from the backward direction, like from 4 to 1, and we'll be taking the maximum. So here 3 is only value, so we'll put 3 here. Then we'll take the maximum of this 3 and 0, so that is nothing but 3, so we'll put 3 here. Then we take the maximum of 3 and 5, so that is 5, so we'll put 5 here. And then we'll take the maximum of 5 and 7, so that is nothing but 7, so we'll put 7 here. So this is how we are building our solution. Anyone having any doubts how we have reached to the solution and how we have dry run on the solution? Any doubts? I'll answer. Just drop a comment. Okay. anyone having any doubt how we are doing this? Okay, now let us look at the time complexity of this one. Okay, if you have any doubt, just drop a comment. So let us talk about the time complexity. So if we're talking about the time complexity, first we are sorting it. So for sorting, the best time we can take is n log n, where n is the size of the array, and then we are, for each element we are calling a union function for both the neighbors, like 2 times we are calling the union function. So that would be, for each element we are calling 2 times the union function, and the time complexity of union is nothing but 2 into alpha n. And how many elements we do have? N. So that would be n into 2 into alpha of n. So in the time complexities we can say omit out these constants. So the time complexity would be n log n plus n into alpha of n. So order of this would be our time complexity, but for most of the cases this n log n is going to dominate this n into alpha n, because alpha n is the inverse Ackermann function, and this alpha n is going to be less than equals to 4 for n less than equals to 10 to the power 600. So this is very large n, and we are not going to get this much n as our input. So the worst value for this could be say 4 into n, and this 4 into n, say for most of the cases n log n would be greater than this 4 into n. So simply we can write the time complexity of this one would be order of log n log n. So but technically it is this one. So this is how we are going to calculate the time complexity, and this is the logic idea and the dry run part. We are quickly going to implement this particular thing, but before that, if you have any doubt, just drop a comment, otherwise we'll move to the implementation part. Anything which we have discussed till now, any doubts you have? As we are not getting any doubts, we are implementing this particular problem quickly. Okay, so the things we need is a vector to store the parent for DSU. So that would be say parent, okay, and then a size, okay, and what do we need else is we need to make two functions. One is say int, so int find function int x, and for this, if so this we have already discussed in the last lecture, so I am not focusing on this much, okay, and this would be this is our unite function or say union function. So we'll be finding the parent of x and we'll be storing it in the px, then we'll be finding the parent of y and we'll be storing it in the py, and if these two values are say not equal, then we are going to check its sizes. So if say size of px is greater than size of py, then we are going to swap this px and py, Okay, and then we are going to make the parent of px as py, and the size of py is going to increase by the size of px amount. Okay, so in this manner we can calculate, we have implemented both the find and union function. We have already discussed it many times. Okay, then let us take our input. So the input would be int n. So this is the size of the array. So say let us take, what we can do is, this is the size of array. So first we can say declare a array, we can declare a vector to store our array, and then we can initialize the parent, say size. So the size would be initialized by 1, so that is nothing but vector. Say for the safer side we will be taking is n plus 5, and it is initialized by 1, and then say parent. So parent would be, will be declaring these, this is nothing but vector int, and this would be n plus 5, and then we'll be taking the iota function to say initialize it. That would be parent dot begin comma parent dot end. So this is what we have to pass in the iota function, and the starting number which we have to initialize. So it would be initializing the parent thing with 0 1 2 3 and in the consecutive integers. Okay, so this is what we have done. Now we can take the input array, that is scene ai. For that, as we have to maintain the index while sorting, so what we can do is, wait a minute, okay. And then after doing this, what we can do is, we can take a vector pair int comma int to store our solution. For this, because we have to maintain the index, so this would be, so the first value would be index, and the next value would, the first value would be the value itself, and the next value would be index. Okay, then we have to sort this thing. Begin and after sorting, and we have to sort it in the decreasing order, so that also we have to keep in mind. Okay, so yes, this would sort my this thing, and then we have to move for all the values from 0 to n. Like the 0 value would be the largest value, as we have sorted it in the decreasing order. Okay, and first we'll be, what we'll be doing is, and before this we have to initialize the result as to store our answer. So that would be vector and result, and for this say n plus 5 we can declare, and we can just mark it, initialize it as 0, and then from here we can we can extract out the index and val. So the val would be store I dot first, this would be our val, and the index would be store I dot second. So this is the index. Okay, now what we have to do is we have to check if we can connect anything to this. So say if index minus 1 is existing, that is it is greater than 0, and if a index minus 1 greater than equals to a index, then what we have to do is we have to take the union of the index minus 1 and index. Okay, and similarly we have to do for index plus 1, that is if index plus 1 is less than n, and if this thing happens, and if index of plus 1 is also greater than equals to a of index, then again we can put the union function for index plus 1 and the index. Okay, and at last what we'll be doing, at say we'll be checking the size of this segment, that is find of index. So this would be max of this value, it should not be the a index, it is better to take value because we have already extracted out the value here. Okay, that would be max of val comma result size of find of index. Okay, so after doing this, what we can do is we can traverse in the reverse direction, that is n minus 1 all the way till say greater than 0. What we can do is we have to calculate the maximum, that is result of I max of result of I comma result of I plus 1. Okay, and then we can just print it out. So that is nothing but for int I equals to 1, I less than equals to n, I increment. For each of this value, what we have to do is we have to just return this thing. Okay, so this is our code. I think we have done everything correctly. Let me check once. Okay, so everything seems good to me. Let me check it for our sample array. So that is 4 5 4 3 and 5 7 is a sample. Let me check for this if it is working correctly. Okay, so we are getting some array. Okay. So the first array is, here we are taking the size as SIZE, it is SZ. So this is an array. Okay, this is an error, and we have one more error. like result, we are using the result here, but here we have the R is capital, so we can make it small and then we can test it. Okay, and it should not be, so why we are getting a 0 here? Okay, it's 5, it should not 5, it should be 4, the size of the array. Okay, and we have already tested it, we have already calculated the answer for this one, and the answer for this one is we have already calculated it, so that is nothing but 7533, and this is what we are getting here. So this is the working code for the problem which we have like discussed in this stream. So yes, this is all for today. This is done from my side. If you are having any doubts, any queries, you can just drop a comment, otherwise we are stopping. Any comments, any suggestions, any queries related to today's streams, today's problems, anything, you can just drop a comment, otherwise we would be finishing our stream. So as we are not getting